Okay. Hi, everybody. Thanks for coming along. It's Friday, 10th of September, and this is Open Source Antibiotics Series 2. And I will now share the right screen. Just bear with me a second. Okay, so here we go. We've had a summer break, so I think there's been some activity, but some people have taken holidays. So I guess we should just sort of try and work through the most important things. And the first thing I was going to mention is really just about, the next compounds that we're going to evaluate, because there were some that needed retesting, and there are some new ones that have come in. And maybe Quillon and Daniel can talk about compounds that we think need to be tested the next round and things like that. Ed has already posted very helpfully the current set of molecules that will be evaluated by Paul Stapleton in this building next Tuesday. So this is a retest of some of these compounds, which previously gave odd data. So in the evaluation of these compounds versus MRSA, the positive control, which is the compound HU2 down in the bottom left there, didn't give any activity. So that threw the assay into doubt. And so Paul said, no problem, he can retest them when he's back from holidays, which is now. And so he's going to have a look at those compounds again, along with the positive control. And he said he's also very kindly said he's very happy to test new compounds that come in. And so those bottom three there with the orange new compounds will be able to go in there too. Ed, Dana, what's the origin of those? Those are newly synthesized compounds, right?
Yes, those are the three that I made.
Okay, that's fantastic. Okay, so we have until Tuesday. So I think those are going to be those, unless any other compounds are coming in. But that's fine because we need the data, right? So
just one more thing on that, which I posted in a comment, that supposedly those amides that we ordered have been delivered to UCL. So I'm gonna try and track them down and put them in this round of screening, and hopefully, we can find them.
Okay, great. It is a big building with lots of nooks and crannies.
Well, yeah, apparently they were delivered late July and no one told me. So now I'm trying to find them.
Right. So that would make more sense, right? Because I mean, one of the points about ordering commercially is the delivery time, if the compound's available, is pretty good. So that would make a lot of sense.
Yeah. So
okay.
Yes, waiting to hear back from stores. Hopefully those will be included on Tuesday as well.
That's great. Okay. So in terms of potencies, I mean, that's
But mind you, I had the same problem with Deliveroo.
Yeah, okay. So that's good. So there'll be some crucial data there that we need to know before we can plan too much more. But while we're talking about this, we can think about if any other compounds are incoming or partly done and inevitably will arrive for subsequent rounds of potency. So I'm Quillon, Daniel, did you want to talk about any compounds that we have not raised here, which may be incoming?
Yeah, I can share my screen, and then I can talk a little bit about the seeds that I've been working.
That'd be great.
And some problems that I have with the purification that I'm trying to solve. Let's start. Can you see my screen?
It's coming, I think. Yeah, there you go. Good.
I'll start the presentation, just 1 second. My computer is a bit slow because I think it's Friday and the computer doesn't want to work.
There it is.
So, yeah, as I told you before, I'm a postdoc here at the University of São Paulo, work with Flávio since 2017. And I've been working with heterocycle synthesis. Imidazopyridine, I have been working a lot since my PhD when I was in Gelb Lab at the University of Washington, during my PhD, I work with some imidazopyridine ureas. I will talk about it a bit late, just to show you some scaffolds that I have working. But so far, I start with this synthesis properly because Flav told me that the position of the nitrogen, the pyridine nitrogen, it's important. The first 3 steps, I have not problem to synthesize. The first step is just a reaction with the proper bromoacetophenone and the aminopyridine. No problem to synthesize and purify. And then the second step is a Menish reaction to get the Menish base. And the last step is the step that I was struggle to work. First, I was trying to optimize using the pyridine, the compound having the proper nitrogen in ortho position, but I was having some problems to purify and get the final compound. Because I had already synthesized this intermediate, have a CF3, I thought maybe I should optimize the reaction, the last step, using this scaffold, then I go for the proper scaffold that we are interested to get. So I try first without any reflux, but I could get the compound in using carbonate, cesium carbonate, 100 degrees in DMF. I couldn't get any, no, sorry. I tried out temperature. Then I tried to heat up to 100 degrees. I got many spots in my TLC. Then I decided to add just cesium carbonate, 100 degrees, and the start material in order to deprotonate the base. And then I added iodobutane overnight, and I could get the compound. So after purification, I get more or less 5 different spots. I analyze all the spots. I always have some NMR signals that show me I have the compounds, but I also have too many aliphatic signals. I was discussing with Flavio, I guess, sorry, I'm a bit confused. In this compound, I get the final compound, no problem. I optimize and then I have the reaction, reflux in 1 hour, then I add the iodobutane and then I get the compound. No problem to purify, and I get the final compounds. Everything was fine. But when I go for the next reaction using the same conditions, adding iodobutane after 1 hour refluxing, I get 5 spots and I purify all the compounds, but I still have too many signals in the aliphatic region, which means maybe I'm having side reactions, maybe with the nitrogen in the pyridine, or maybe in other aromatic positions, because sometimes I don't have all the signals of the aromatic region, but it's missing 1 hydrogen, and then I have more aliphatic signals, which means the iodobutane it's reacting with other positions of this imidazopyridine having the nitrogen in this position. This is why I don't have yet this final compound. But I have this one with the CF3 and without the nitrogen. Then I try to work with iodoacetonitride because it was the one that I have in the lab just to see if the reaction would work with this one. And the reaction didn't work. I just recover start material. I order the other chemical, the other iodo alide. But here in Brazil, we have problems to other chemicals. Sometimes they take like 1 month, 2 months, 3 months. So I don't have this iodo yet. And then
do you have bromopropane? It might be worth a shot.
Yes, I have.
Might be worth trying alkylating with bromopropane, same conditions.
Yeah, that would be great. Because iode is too much reactive. Maybe yes, I think I have your bromobutane. I can try today or maybe tomorrow this reaction because. So I discussed with Flavio maybe and other researchers in our lab, and they told me to try to purify using biotage, but the problem is not the purification. The problem is getting too much spots in the TLC, and analyze all the spots and I get its side reactions that it's occurring. So far, what I have now, so I have the intermediates. I don't know if you would like to test the intermediates, which kind of compounds you already tested. So I have this 5 intermediates, and this last one, I still have to work, but I have this one with the fluorine, another one with the CF3, and then the start materials. I could send for you, or we could wait more until I get more compounds. The set of compounds that I was working during my postdoc and also PhD, and I still have the compounds, are these 3 scaffolds. The first scaffolds are imidazopyridine, pyrimidine ureas, having substituents in R1 and R3 positions. Then I have these scaffolds that I work with many bases. I have many substituents in R2 position. And then I also have fluoropyridines, which are related to the other scaffolds. More or less, I have 24 analogs. We test all these 94 analogs against T-Cruz, T-Brucei. Most of them are active, has some potency against parasites. And here I have like 30 variants having urea, basically, or amide also, but urea is better than amide in case of parasites. Here I have booking amino groups in this position. That one I have aromatic and aliphatic. And in the ring, into the ring, I have nitrogen or oxygen. We published this paper, this works. The first one when I was in Gelb Lab in Seattle, and last year worked with Flav and also Professor Wunsch in Germany. We published another paper having this related series of compounds. I just would like to show for you that I have those compounds, and if you are interested to testing, I can send also for testing. Thank you.
That's great.
What I would like to talk.
Thank you. Anyone got any comments straight off the bat?
Is there any concern about these being patented?
Yeah. The first compounds from this paper, new class of antitrypanosomal agents, they are patent. They are patent for T-Brucei and T-Cruz. The second paper we didn't patent, so it's more this set of compound having substituents in R2 position and also fluoropyridines. We tested them against T-Cruz and T-Brucei. But if you'd like to test, I have the compounds. I can talk to Gelb. I don't think it would be a problem because I already sent these compounds to other biological assays. For example, we tested here in Brazil against Leishmania. They are not active against Leishmania. They are most active against T-Cruz and T-Brucei when I have urea in R1 position. The most active compounds, I have the urea group in this position. But this scaffold, the second one, 1,2-A pyridine, they are more related with the antibiotic project.
So, I mean, the answer to the patent question is that if we're testing against most of them, we're in the clear, right? Because it's a different function.
Yeah.
Except that there will be composition of matter patents covering the compounds.
Will I mean, that second compound is, sorry, the patent that's listed there has the function of the compounds. Do you think that would, doesn't that mean
we could have the structures as well though, won't it?
Yeah, but okay.
Yeah,
but
But the antiprotozoal compounds are the ones with the substituted R1 urea.
Yes.
We don't have anything on our ring, so how similar is it then?
The patent covers the first scaffolds. the first scaffolds having urea, because all the activity are related to have a urea in this position. For example, when I change the urea from R1 region to V region, compound lost totally the activity. So the scaffold that we patent says that I have to have urea in this position. This second group of compounds, it's totally different. It's from my postdoc here. We didn't patent. We publish a red, and we don't have urea in this scaffold because I would like to explore this region, because in my PhD I didn't explore this isoindole region here.
My sense is that, I mean, that's fantastic, and it's a very kind offer. My sense is that we want to avoid we want to avoid what's it called? Mechanism of action switch. So we want to avoid moving to a different mechanism of action. It seems to me that the ones that would be of most interest to us, in terms of the bottom structures on your slide there, would where the R3 is pyridile, right? Because then we know that that's essential for activity in our case.
What would be very interesting would be to make a compound using that furopyridine nucleus, where you have V as a carbon atom, and then you have basically furopyrazine, and then put our normal substituents. That would be quite interesting, but that would probably be pretty difficult to make.
So Daniel, do you happen to know if of these 94 compounds or so, you have several where the R3 substituent is an orthopyridile?
In R3 position, most of the substituents are aromatic. Some of the compounds I have fluorine. In 2, 3 position, 3, 4, or 4 position, fluorine, chlorine, bromine. Some compounds I have bromine.
These are all phenyl.
But I don't have aliphatic groups in this scaffold. I have aliphatic groups in the furopyridine scaffolds.
Right.
And here in R2, I have buckyl aminoacyl groups like piperazines. I have here. I have aromatic as well. Yeah, those kind of things. But the nitrogen, that specific position that I know that is important for the mechanism, the mode of action, I don't have any compound with nitrogen in that position. I have from my PhD maybe furan, but yeah, it's over the compound. I synthesized just few milligrams for testing, and were not active. We didn't keep it going with furan, or isoxazole also was not activity.
Right. So for R3, is it mostly phenyl rings?
Yes.
Okay. And okay, because I mean, I guess we just have to be careful we're not screening too widely here. You know, we're still interested, obviously, but not necessarily for this project if we're gonna change that too much.
Yes.
I mean, do you happen to have a sheet where the full structures are shown anywhere, so you can share those with us without having to do too much work?
Yeah, no, yes, I have the CDD. Maybe I can access. I'm going to stop to share my screen just for 1 second, and then I can open the CDD, and I can show you the scaffolds.
Okay. While you're doing that, what do other people think? I mean, it's great to receive compounds, but it's absolutely fantastic. I just want to make sure we're trying to remain have a focus on the current series.
The issue now is we don't have any MOA. Everything is speculative. Speaking of MOA, what happened with Gray's lab? They were going to do it on human cells, like HeLa or something, to see if there were any possible cross-link, reactivity.
Yeah. So just on the MOA stuff, Lee was wanting a source of MRSA lysate. He doesn't have that source anymore. So he's done some initial experiments with that, but no longer has MRSA lysate. He was asking us for a source of it.
Should we ask, do you think it would be worthwhile doing these pull downs on, human targets so we could have a possible look back of seeing, oh, this could have, X effects,
Yeah. So I don't think
I know
so.
Todd's
We
was
can,
a bit high on some of these compounds, right?
so we can access MRSA lysate in our building. The person who does that, which is Paul again, recommends strongly against trying to ship that overseas just because it doesn't survive.
Yeah.
So in the meantime, I mean, it would be very nice to be able to try and identify a source of that in the US. I don't know how we do that. And in the meantime, yeah, I think Lee could productively do the experiment on a mammalian cell line, in part to address the issues of toxicity.
Yeah, like heck or helolysate.
Yeah. So I've already suggested that to him, and I'll see what he comes back with.
Can you not just put a request on the Twitter feed and see if anybody?
No, I did. Yeah, we did, and I think we need to do a bit. I mean, that was speculative. I think we need to do a bit more targeted reach outs.
Yeah.
I mean, the issue is though, it's not really. I mean, how stable? It's not stable for shipping.
Yeah, I think it just locally produced recently will be fine. I think just leave it a few days and put it in a FedEx box, and it probably won't end up being so good. So I think within the US, maybe, close to Lee would be good. So if we could try to do some reach outs to see if someone's willing.
Well, if you post it on the OSA Twitter again, I've got some contacts there. I'll point them towards the tweets if you like.
Okay, that would be great. Thank you. Yeah, let's do that.
Could we use like the Farm Alliance mail serve or something? Because I mean, obviously they would be at UNC if they're biologists on that mailing list, and they might be helpful.
Yeah, right. I mean, I'm not sure what the issue is because it's not financial, because this is a grant supported project, so we can pay someone to do it. So yeah, it's an idea.
Sorry, coming back to the human to the heck or HeLa tests. Do we know if Lee has enough compounds to actually run it on human cells?
He does.
He does.
Yeah, he's got it. All right. These are the compounds. Okay, so there's the phenyl ring. So we would be pretty confident that those compounds would be inactive because of that phenyl ring.
Yeah, those ones are not patent. Those one is the one that I published last year.
Okay.
These compounds I synthesized here in Flavio's lab, there are other compounds that are related to those that I have here. Fluorine in this position, for example, that I synthesized in Germany. Is not problem also to send for you because it's not included in the patent. These ones are amine. Those were not active against Trypanosoma cruzi and Trypanosoma brucei.
We're sweeping pretty far away from our core structure now.
Yeah, I agree. Those ones are related to the patent. From up to here are not related to the patent. They are new compounds blended here with Flavio and.
I mean, some of the shorter, remember, the pyridine is pretty much needed, but maybe we can break away from it. But then the question
about that.
What I can do, I can organize the data that I have, those compounds that are related to this scaffold, and send to you or post there, and then you can take a look and let me know if you would like to test 2, 5, 10 compounds of this set. I can send to you without problem.
Okay, thank you.
That's a good idea.
Yeah, I mean, a grid of the structures as well, just to get our creative juices flowing, would be very useful in the way that you're doing that. So we could browse those. That'd be fantastic. Yeah.
So to go back to your synthesis, have you any ideas about what the problem is?
When I try without heating, I couldn't get the product. So when I'm heating, I guess side reactions are occurring. So maybe the nitrogen of the pyridine is also because it's refluxing and overnight reaction. maybe the nitrogen of the ring is attacking the iodine, because I have some compounds that doesn't move in from the base. Maybe because I have CF3 group. I don't know if the CF3 is too withdrawing, and then some reactions are occurring.
I mean, you're parafluoro on the one that you got problems with, don't you? Which presumably makes that nitrogen much less reactive.
Yes, yes. And also some NMRs that I have, it's missing one aromatic hydrogen. And I have more aliphatic signals. And I have a limitation here right now that I cannot perform mass spec, because then I could check what is the mass of the compound, and then take a look to analyze which compound is. But they are super polar. They don't move from in the silic. So I need to use, for example,
maybe you're getting quaternization. You're getting quat salt, maybe.
Yeah, so something I just want to quickly add in here. When we do the N-alkylations, depending on the stoichiometry of the iodide or halide that you're using, you get a mix of alkylation of the core nitrogen, you get alkylation of the pyridyl nitrogen, and you get an alkylation of the desired nitrogen that you're after. If you go heavy-handed, you also get quaternization of that nitrogen. So we follow all of these reactions by LCMS, and when you're doing the purification, in our hands, we tend to find that the pyridyl and alkylated product and the desired product run quite closely on silica.
Okay.
Is there a chance of alkylating your amine first and then doing your manage?
Yeah, I'm thinking to do that also. Try to do the alkylation first, and then try to work in the managed conditions to get the compound. Maybe it's a bit easier. Flavio thought about this route, and me as well, because I had the compounds read. So I just need to make one reaction, the alkylation. But the alkylation takes too much time. And I have another problem, many problems with COVID. We can work in the lab just 6 hours per day, which is 6 hours for me. It's nothing. I was commonly staying in the lab the whole day. Then I had 6 hours and many projects, and so I need to split my time. This is the problem. I hope soon we can start working full day. Maybe I can accelerate my synthesis, but we are in these conditions like the beginning of the year. So, and last year, 9 months without going in the lab. So it's kind of complicated situation here.
Yeah,
it's
terrific.
tough everywhere, isn't it? Yeah.
Yeah, we sympathize very much.
Yeah.
So, I mean, but based on that, though, I mean, we would love to test that one compound with the CF3 that you managed to get there with the alkylated group on it. I mean, right, that's useful, right, in terms of our SAR. I'm pretty sure.
Yeah, I mean, I think even as a stopgap, if it's going to take a while to get a next round, I would say the NH intermediates are not, unuseful. I think those might be worth it also.
Right.
I can prepare a list of compounds with the previous one that I have and those new one, and then we pick up together which compound would you like to ship. And I can use FedEx, and FedEx here in Brazil, it's pretty fast. I think 2-3 days would be there. So, and I can send the first set of compounds, and then we can have idea about the SAR and work for the next set.
Yeah,
That sounds like a very good idea.
Yeah, it'd be great. I just want to, I want to make sure it's not too expensive for you, because, sending a handful of compounds is the same as sending a lot. So if it's not a big problem, then we'd love to receive them sooner rather than later, I think.
Okay, I will try to organize the set of the compounds today afternoon, and then maybe Monday I can ship the compounds.
That'd be fantastic.
Yeah. I'm just sort of thinking on my feet, as it were. Could you just change the chemistry completely and try something like a carbene insertion into the NH bond?
Yes, I thought that as well. Or maybe trying to stand off managed reaction, try another reactions in the isoxazole portion. I saw one reaction couple of days ago that I could easily manage. I think would be easier. The first thing that I'm going to do today is try with bromine, a stand of iodine, because I have the intermediate, and then I will try the amination first and then manage reaction, and then I go for other options, because purification could not be a problem for the last step.
Just so you can also utilize the intermediates you already have you tried doing a reductive amination as opposed to alkylation?
Yeah, no, not yet. I can try also that one. Flavio, I was talking with Flavio yesterday about that. I can try that one.
You might want to consider adding something like a Lewis acid when you do that reaction. I found that those nitrogens aren't particularly basic enough to get that reaction to go forward.
Yeah.
Okay.
All right, great. Thank you. So yeah, forwarding compounds that are available, and then we can make a decision and then ship. That's awesome. Thank you.
Okay. Thank you.
All right, cool. My memory is hazy because of the summer holidays. Were we expecting comments from you guys, or have we?
We have some that I haven't been able to successfully purify. We're actually handing this project off to some undergraduates that are coming through our lab in the next week or two. We definitely have 2 undergraduates coming in. How we're divvying up the labor for the projects, Laurie isn't quite 100% sure on yet. We'll have a better idea by next week. I spoke to Dana offline about some compounds to synthesize of interest. Namely, it was compounds where we do a nitrogen scan around the core itself. So we have those compounds on hand. So we can just get the undergraduates to purify those. And there was a few other compounds that have been on our to-do list that we've now sort of refined and now handing on to these undergraduates when they come.
Okay. All right. Great. If those projects are set in stone and there are targets there, if you were able just to update us on the specifics of those targets, that would be very helpful, just to make sure we know exactly what they're trying to purify and make.
Yeah, when Laurie gets back this afternoon, I'll be able to sit down with her and we'll put a list together of compounds.
All right, fantastic.
We're going to hand over to them.
Thanks. Great. Okay. So that all sounds very promising. So I mean, those are the main things. As I mentioned, when we were just talking about the MOA stuff. So yes, as I mentioned, we pushing Lee to see if he can do some human cells while we're figuring out what to do the MRSA, and then we'll send out another tweet for you, Chris, to send around. And if other people can retweet or do a bit of searching about an American site that might have some MRSA lysate available, that would be very helpful to try and resolve this. Okay, so I think we dealt with all the synthetic chemistry stuff. We have not much more to do with the ADME stuff. As I understand it, Dana, Alex is finishing off her table of tox data, but I think is away at the moment.
Yeah, she's on leave. I think she's just on holiday. She said she's back at the end of the month, so I'll reconnect with her then and try and see if there's an update.
Right. Okay, great. And then I guess, again, another thing which I wasn't sure to what extent we were supposed to be doing anything here was on the oh no, that's the same thing, right, that we were just talking about.
Yeah.
Okay, fine.
So I color coded that a while ago. So I think we can probably get rid of this. And then the compounds in issue number 86 are the ones that we decided to ship following the analysis of those results. And so we're just waiting for results back from those from DNDI.
Okay, so that's still live, right? That's what I was thinking. Okay.
They're sitting in a FedEx box behind me now.
Oh yeah. Okay. Okay, fantastic, great. So that's happening. Okay, great. Whoops, sorry, my connection's being slow. Okay, and then I think those are the main things, right? We don't, I think that's everything that we're currently waiting on, as far as I can tell. Have I missed anything major? So I think that the retest and the test of the new compounds will be in before next week, Friday. So I think provided we get those data, let's have a look at them. And if we don't get a chance before then we can have a think also about Daniel's compound as well next week. So hopefully we'll have potency data and a decision to make about compounds that we might want to use. All good? I think that's everything. All right. Thanks
Bye,
for coming along,
everyone.
everybody. Really appreciate it.
Right. Thank you. Bye.
See you again soon.
See you guys.
See you
Bye.
soon.